Hi, and welcome to CI Live Virtual. Today we're going to look at the details and some product solutions for getting stucco right on buildings. First, we're going to visit some local job sites to see how stucco and stone products are typically being installed, including WRB applications and some of the flashing systems. After our visit, we'll return to the CI Live facility to look at some common materials, tests, and some physics around the problem. Oh yeah, and a little BS or building science from the CI Live team to get a handle on what the issue is. Lastly, we're going to look at some of the mock-ups we have created at the lab to accelerate drainage or water release, and some ideas for ventilation of masonry applied claddings to enhance the durability, reduce callbacks, and put a modern twist on masonry applied claddings on buildings. Let's go to Justin and see what he's up to.
So here we are in Denver, Colorado in the Beeler Park neighborhood. A lot of different modern architecture styles that we see around us, and one of the things that we see with that modern architecture is there's been this desire to have multiple claddings on these houses. And you'll see everything from board and batten or panel applied cementitious siding. You'll see stone, you'll see stucco, you'll see brick. And so all these different types of claddings and masonry claddings are really sort of driving the bus here of the different types that we see. And that typical masonry cladding that we see is really constructed over an OSB sheathed material with typically 2 layers of grade D paper. Sometimes we'll see out on this site that there's a layer of some weather resistive barrier, then a layer for the intervening layer of a grade D paper over the top with expanded metal lath. And really what we're trying to do with this second layer is this is a debonding layer. Almost by building code you'll see this almost everywhere, and that's this debonding layer. This is my weather barrier layer here, and typically connected to different flashing materials, we hope. So we see expanded metal lath, and then we go to a scratch coat, then maybe direct applied stone, or if it goes from scratch coat to brown coat to color coat for stucco, and that's a typical thing. What we typically see here is a 2x6 wall, and here we've just constructed a mock-up. We're in winter, so there's not a lot of active stucco projects going on right now today, but typically a 2x6 wall, R20 plus insulation cavity. Sometimes there's a vapor retarder, not typically in the Denver climate that we see that, and then wallboard, drywall on the interior side, but a fairly simplistic thing. We start to see the attachment of different staples to the lath, where you see abundance of staples and things, and so those are critical layers that we see here. But really what we're focusing on today is there a rain screen product that we see typically applied here? And the answer is no. We're in the Denver climate. We get about 17 to 18 inches of annual precipitation per year, but I'm going to say with these modern constructed buildings, even in this climate, we're starting to see issues with lack of drainage of these reservoir cladding or masonry materials. So there is even a need that we see here. In fact, I've seen failures on houses less than 2 years old where we've actually had to take them apart and figure out what's happened to it. And what it's telling me is if we had a rain screen out here and the proper application of different flashing details from base of wall to windows and proper detailing, we could have easily solved some of those problems. So let's just take a look at some of the houses that we've got around here and figure out what types of cladding that we have, and if we spot any problems or things that we can go back to the lab and take a next step at. So here we have a sort of thick column to the porch on this house. It's framed with wood framed materials, sheathing, and then this thin brick is applied to it, to the patio, and I can see that it's a thin brick material. What I want to do is we see one right behind us in the next house that doesn't have the thin brick applied yet. This is going to be a lot like a masonry stone veneer that we'd see on a building, a scratch coat. This thin brick gets installed. But let's just see what the layers look like beneath this to figure out how they're effectively dealing with water on this particular critical application. So here we've got this thin brick prep, and you can see at least they're using a draining weather resistive barrier. That's a really good first step. Next layer you'll see is that the grade D paper will go over the top of this, expanded metal lath, scratch coat, and then application of thin brick. But what we can see is we've got structure behind here, and we've got treated lumber directly in contact with this porch And then you can even see the weathering that's happened before this is even covered up with this OSB material. But they're going to probably flash this, come down, again, grade D paper, and then the subsequent layers go over the top of it. So you look at that and go, wow, are we creating some way of draining and releasing water? We've got a pretty good start here, but what we really want is a clear 1/4 to 3/8 inch drainage space between this material here and the actual scratch coat. All right, so here we are on another building looking at some of these different claddings. And so this is a split-faced stone that's been adhered directly to a scratch coat. And here you can see this tall, thin section where they haven't finished it yet, but we can see the scratch coat behind it. And note that we've got a roof that's actually area that's abutting this as well, so we've got to integrate into that. But also on the left and right sides, we're going from a cement panel siding to a lap siding over here with basically a 1x4 strip that's edging both of those. So we've got this thin, looks like about a 6-foot wide patch that goes 25 feet into the air of stone on a scratch coat with expanded metal lath and two layers of grade D paper over a wood sheathing. So this is a technical challenge. We think about flashing it, integrating it into the building, and then how are we draining it? When we look at that scratch coat and even following this, it's an open joint stone that's on here as well. We can see even at the bottom of the wall, there was basically nothing down here. So I'm actually reaching up and I can feel the OSB right here on this bottom edge. And then there's a small piece of metal that's just a J-stop. It's not even a weep screed. I don't feel any holes in it. And then the stone is right here on that scratch coat. So pretty basic install. When we look at trying to deal with inclement weather. This is on the windward side of a building. This side of the building is going to be hit with water every time it rains out in this particular climate. So something to really think about of how we both detail these different claddings, but even just providing drainage through this long, tall, slender wall right out the bottom, or ventilation.
As you're seeing some of these issues about reservoir claddings, we're going to talk very briefly about some of the concepts that are important. Now, when we look at reservoir claddings, we have to look at all cladding types. And one of the key fundamentals that we have to look at have to do with things like climate. Now, when we want to look at things that matter, we're going to call reservoir claddings that can take on moisture and store them. Now, that includes things like wood and cement siding, as well as stucco, single coats and traditional stuccos, and brick, and even stone with a strong mortar basis. So these are all claddings that have a tendency to take water and hold on to them, and in some cases, based on orientation and other aspects of climate, can change in the direction in which the moisture dries. Sometimes it dries to the outside, which is often the case, and other times it can be driven back to the inside. So solar-driven moisture, they call that, is when the sun strikes this reservoir cladding, can actually drive it behind the cladding to its next iteration of where it's going to go, whether it's going to be vented or whether it's going to be driven through some substrate, some material, which will then be dependent on its permeability. These are for longer discussions, but just so you get an idea that what we're trying to achieve with cladding systems is to understand how they behave, what the rest of the assembly is like, what climate it's in, and should there be a concern if there are impacts that the reservoir claddings might create beyond its facade. So when we look at climate, that's one of the aspects. So the first thing we'll look at is things like code. When we look at the code variations, I find the codes are less relevant to things like how we provide treatment for our claddings. The system that you provide for your cladding should be based not on code, but really on climate, application, orientation. Those are the kind of things I think really drive that. We can also look at things like U.S. rainfall and finding out where is the rainfall more significant. Obviously places like Philadelphia or the Pacific Northwest, the East Coast, the Southeast, those can all be areas with greater amounts of rainfall, meaning that they're more subjected to longer cycles of the cladding absorbing moisture, staying wet, and potentially being affected by that solar drive or that vapor drive that we don't always have control over. So we look at rainfall. We can also look at things like relative humidity and how that behaves. How are climates where the moisture levels are elevated, both on the cladding type as well as the inability for it to dry back to the outdoors? If the outdoors has a very high dew point, very high relative humidity, oftentimes we'll see that it gets driven back to the inside where it's being air conditioned and dehumidified. So there's a lot of complexities going on here. So what we want to do is try to ensure that our systems are designed correctly. Now, if we look at the evolution of what's gone on, we see that things like thermal insulation have changed the way in which buildings perform. Lack of heat loss or heat flow in the building assembly, which is caused by lack of insulation or increased insulation, allows us to change the way in which this energy flows. More insulation, there's almost no energy from inside the building driving through to the outside, which also in the past had helped dry wall cavities and assemblies as well. Now we know that we're getting greater insulation levels in wall cavities as well as even on the exterior of the building. We know that thermal drive is different than it used to be, and that's added to this complexity and added to this challenge of looking at how building performance really affects the overall issues. So we look at thermal insulation and that improvement. We've got fiberglass and cellulose and mineral wools and all kinds of things that we've changed in cavities. We've also added things like spray foams in roof decks and in walls that have really changed the way in which energy flows across these assemblies. So if we're not careful with how we manage these things, not careful with the sheathing types, not careful with these moisture drives, we can really cause buildings to fail prematurely and unfortunately quite quickly. These assemblies end up being stucco claddings that we're driving moisture through, being trapped at vapor retarders on inside of walls and all kinds of complex issues. But thermal insulation and slower drying cycles really creates a challenge for our wood substrates that are all part of the way we build today. So if we look at the common threads of heat, air, and moisture, if we look at reducing the heat flow, reducing airflow by building tighter buildings, we then have to manage this moisture element much more significantly. When we look at the control layers that we're always dealing with, we have the thermal control layer, air control, moisture control, vapor control, structural control layers. These are all the layers that are essential for us to make sure that we're paying attention to how they affect the product choice, how we put these assemblies together. Each one of those layers matter. Sometimes a product can perform multiple layers and multiple functions, but we have to really design intention into those choices. So if we look at solar-driven moisture, for example, it's the idea we've mentioned before that rain on our reservoir claddings gets hit by the sun. So as you can see, it kind of moves through the assembly. The sun heats up the outer surface, driving that moisture to the back side of wherever that might be. Could it be interfaced with a piece of sheathing, a piece of building paper, or a cavity, or a product that inhibits the drying in that direction? So those are all things that are critical, as Justin's laid out with you in the cladding types that he's explained, how there's different materials that can be used to provide adequate drainage, a reduced ability for vapor drive to occur, and also a cavity that could dry and drain effectively. The idea about looking at solar-driven moisture is about what's the climate we're in, what's the cladding type, what's the system design, what sheathing did we pick, is it gypsum, is it OSB, is it plywood, is it foam? Those are all matter, and then orientation, what matters most. A building facing north, that north side surface will see less solar drive, obviously, getting less solar exposure, and a south wall, west wall can see more solar drive. Finally, when we look at products, we look at types of building papers, weather-resistant barriers. Some weather-resistant barriers have different performance characteristics, and sheathings have different performance characteristics. As we look at the way in which water affects our buildings, we've got to make sure that we're flashing everything away from these claddings, making sure that we're doing a careful job of installing our cladding systems, especially things like stucco and stone and brick, to make sure that if water is going to be in those areas, it finds a place to quickly drain away so that it can be removed and not stay within the assembly, so that the material itself will hold some moisture, but we don't add extra liquid water to store and stay in the system for too long. So if we look at the idea of how claddings get installed, you'll see that sometimes stone claddings get installed. The back side of the stone cladding can get filled up with mortar, and then the back side of that mortar is a piece of black paper laying on a piece of OSB sheathing, and that's a more risky assembly. We realize that there really is no opportunity for a lot of liquid draining. There's not a good chance for air to dry that assembly, so we'd say this would be a more risky assembly. When we look at these details, this is a part of a graphic from Building Science Corp. You can see the picture on the right and the picture on the left, but these ideas showing stucco and stone applied claddings, for example, on a scratch coat, all represent reservoir cladding systems. And you'll see in all these assemblies, it talks about how critical it is that there's a scratch, and however we decide to layer those up, whether they're single scratch, brown and finish, or whether they're just two-layer systems. We have this in various climate zones. But if we look at the idea of having a drainage mat, a drainage medium, which is what Justin has showed you previously, it's really critical that we understand it. The stucco systems and these stone systems in the mortar joints, they will allow liquid water through. So as the moisture, liquid water runs through, we want to capture that and drain it quickly. If you remember the assembly Justin showed, it showed when he poured water into it, they had drained immediately out the bottom. You could see the water pouring out the bottom of the assembly. Think how critical that is to get that liquid water away and let whatever water is stored within the cavity, or the assembly, I should say, that it can then dry more quickly using airflow, or letting the sun do that without having it driven back further through the assembly, potentially into the sheathing or into the wall cavity, which would be even more detrimental. So I think the strategy here is that we look at how building assemblies are put together, how we look at things like vapor drive, reservoir claddings, drainage systems, and products that inhibit or reduce the flow of this moisture through the assembly. All of these are critical components. So as you design your systems, take a look at things, like I said, as orientation, the type of product, rainfall. How am I going to design my system to be responsive to my cladding choices, that as I add thermal insulation to slow down drying, I've also added systems to improve the long-term durability. This is a great strategy, a great lesson to keep learning, and there's a lot more. We look forward to talking to you more in CI Live, but thanks for spending a little bit of time talking about this segment of building assemblies.
Okay, we're here in the CI lab, and like all things, we love to test things of performance in the lab. So we've built a couple of different mock-ups here, the same two, but we're going to test two different products for drainage efficiency. So we're resembling an ASTM drainage efficiency test. This time, though, we're using a quarter scale apparatus. So we've got two different products that we're going to test, and you can see there are other products that are surrounding us, and they're rain screen products. So they're all going to be effective at draining water, but the point of this one is, even if just these two right now, which one is the most effective at evacuating or draining water behind it? So what we've done is we've built a frame. It's a 2x4 section of just wood framing, and there's a piece of Lexan here. And to push that rain screen product against that Lexan, we've taken a piece of 2-inch extruded polystyrene foam, and then we've screwed it very tightly down on the edges to try and compress that down here. So that'll be our test specimen. So we've built two of them, and we're going to catch the water down here in these buckets in the bottom, and then actually go through and weigh how much water is actually in the bucket versus what's left in the wall. So as we take a peek at some of these, and so we've got a scale and a device to catch that. So this will be our first sample that we do. It's labeled B on the bucket, but that's the first one because it's closest to me. And this is our first product that we're going to look at. And it's an entangled woven nylon mat as a rain screen product with a facer on the front that is for a layer to catch any mortar. So you'd put your lath directly atop this, your scratch coats, etc. And so here we've got this entangled mat that you can see, and so you can see it's an interwoven fiber, though it's got very good compressive strength. This product is about 1/4 of an inch thick, so probably right around 6 or 7 millimeters if I'm going to put that into metric mode. So really our first part is we're going to take this sample and we're going to run a 15-minute test for that water drainage for both of these. So we're going to dump the water into the top of this tube here where we've built a rain shower, and it's going to come through this product. We're going to then let these products stabilize for 15 minutes, and we're going to collect and weigh the water samples to figure out how much is in the wall versus what's there. And the water weight that we're going to put in is 1 US gallon or 8.3 pounds. So as we first grab that, we'll get things situated here, and I'm going to need a step stool to get up there. Here we go, and we're going to dump this water in the first sample. There you can see that water hustling out of there. Wow, that's something. So you can see the effectiveness of a rain screen as this rapid drainage element, and how fast that water is sheeting down that wall system from our shower head. And it's collecting quite rapidly into the bucket on the bottom. And there you can see the water running through here. You can see some is trapped on the surface. It could happen on OSB as well. And then as we look closely, you'll see some of those water droplets will be perhaps even trapped on the nylon fibers that are in there. So now we're ready to test the Durkin products. We've got the Delta Dry Stucco and Stone product installed on the second mock-up. So we're going to go through, and as we set our timer, we're going to go through and dump that water into that second one as well. So here we go. All right, here we go for the second product, the Delta Dry Stucco and Stone. And we're going to do the exact same procedure. It's pretty exciting to see that water run so quickly out of that product. Now let's check this one. Oh, got some more spill in there a little bit. That's some really fast water movement that we've got going on through there. Wow, you can see the water just racing through there. It just has this, it's a molded product. It has those little standoff legs on it. And to be fair, when we talk about this one, this would be the emergency drainage system, because really we're going to show in a later clip here, we're going to show how fast the water actually drains on the front of this product as well, because it's an impermeable membrane, so we're draining water on the back side, but we're going to show later how fast we can evacuate water from the front side. So this one actually has kind of a dual drainage function, and this side's one of the drainage functions, but also provides ventilation of air through here as well. So that's pretty darn impactful. So here we are, we're waiting just about another 15 minutes on this one, and then we're going to take both of these off to the scales, and we're gonna weigh them in and figure out how much water is still left in the walls. But hopefully you find that exciting, that a rain screen product on how we can evacuate water so quickly from behind masonry cladding materials is something that we really have to think about from a durability perspective. All right, our 15 minutes have passed, and it's time to weigh our samples. So we're going to start again with the blue, which is sample B, and figure out what we've got in this bucket. We started with 8 pounds, 3 ounces, basically 1 gallon, and we're just going to dump this water right into our scale. And get to the last drop. And with this guy, sample B, we have 7 pounds 10, we'll call it 7 pounds 11 ounces that have been evacuated from the wall. And our second sample, the gray side, there's a lot of water that went in and a lot of water that came out. And we should see the same thing out of this side here from the backside drainage test of the Delta Dry product. And just about there. And here we are at 7 pounds 13 and a half ounces. Okay, so the numbers are in from the weighed samples after just a 15-minute increment. And the blue sample, you can see, sample B, we started at one weight, ended pretty close, pretty darn close, within about 5 or 6 ounces. And so in that 15 minutes, we had 93.9% of the water had evacuated in 15 minutes. With the gray sample, the dry product that we've got here, we see that we've got 95.8% drainage in 15 minutes. So a little bit faster. And I do want to remind us that this was the drainage surface we were looking at, is the drainage surface on the back, and to point out that there was a drainage surface we have yet to test, the speed of which we're able to drain down these vertical channels on the front. And that's one of the magic parts about this particular membrane product. It's impervious. So it's a pretty fun test, though. As we can see, the main takeaway here is that rain screens work in rapid drainage. That's rapid drainage in both examples, just one even more rapidly. So here we are in the shop to put some of these details of the test and look at a few of these product applications to put rain screens and inclusive with the Stucco systems. So here's our first mock-up that we've put together. And just to go through several of the small details, the first thing, and you'll see us talk about this quite a bit at CI Live when we do water spray rack testing and other things, that we've got a piece of flashing that's down here. And that piece of flashing was installed before the weather barrier and any of the other flashing materials. And it's a peel and stick flashing that's extended down onto this pretend foundation and then up and behind the weather barrier onto the face of the OSB wall. And that's really to protect things from splashing up at the bottom, and also is a really good way to terminate or detail the air barrier. The next step is that we've got this metal flashing. This is not the weep screed. We're going for a Stucco assembly here. This is not the weep screed assembly. This is a piece of diverter flashing at the bottom of the wall to kick that water out and off that assembly. We'll get to the weep screed shortly. This layer of flashing is integrated up behind the weather barrier and then sealed off to maintain both to some water holdout and our air barrier detail. So that's that first piece. Now this Delta Dry Stucco and stone product is going to be applied over the top of our weather barrier and flashing system. So that's our first piece. So we've just pre-cut one small piece to go on here, and we can just install standard staples. We've installed 2 of them up here already, and I'm just going to come right along the edge of the wall and install a few staples just to hold it in place. Okay, and so at this point, we've got the product rolled out and installed with a few staples. We're going to come back and switch nail guns. Be just a noise here. I'm going to a different fastener. And we're going to install the next piece as one of our first accessory metals. This is going to be our bottom of wall termination or weep screed. And we do have some holes in here, and that's to release any water that's kept into that masonry cladding or the masonry structure, that we can weep that water out. That's what they call a weep screed. And we're just going to simply install that right to the bottom edge on the wall where our Delta product ends, and we're going to nail it into place with just several nails. And you can see that it dents it in a little, but it's hardly even pushed in that rain screen product. So now we change gun again. And now we're ready essentially to install our lath. And this particular product has a receiver sheet on it. We'll talk about the variations here shortly as we go on. But my weep screed goes on the front, and here now my expanded metal lath lines up and is put into place. And all we have to do is then, this will be a few more staples. We're going to use a 6-inch vertical spacing into the stud framing. That's a typical requirement. And we'll just put a few. So there we are. I'll leave a few ends loose. But basically at that point now we've got our metal at the bottom. So you can see we've maintained that gap where our diverter flashing works to kick that water out away from the wall. The weep screed to weep any water that's charged or held into that reservoir cladding, the Stucco material. Our expanded metal lath, we're ready for scratch coat and the subsequent layers to finish this job up. So that's pretty darn straightforward and fast for an install. Now, we're going to go over and just look at another wall that we've put together here. And we've done one to completion. And here we are to look at a few of the details at the bottom of the wall. Number one is we completed the same detail down here where we used a piece of peel and stick flashing to extend to the foundation behind onto the raw OSB or wood framed structure that lies behind it. The weather barrier layer then is lapped over the top of it, and we've seam sealed that one off to maintain our air barrier continuity. Now, we like to try different products here at the CI Live facility, so we got our hands on a different product. It's not a metal product, but here it's an extruded PVC product that has a flashing channel built into the bottom area here that you can't see, and then it actually has an integrated weep screed component here on the top side that the rain screen product actually lines right up into and facilitates that drainage here of what might become on the back side of this wall. So the next pieces here that we have is we've got a different product with the same dimpled membrane. It comes with a wash-treated fiberglass lath on it, so not a metal lath. So this one's even faster to install because I don't have to deal with a lath. It's integrated into the roll. Nice thing is you can see it's got a wash-treated lath, and you can see where it's doubled up here. There's more of the fiberglass material. That shows my basic 6-inch nail spacing increment. So what we like about this product is you can see where you nail it, but you also see this grid pattern that you can easily sightline where there might be a stud or another accessory that's going on to kind of help level things out, should you level this product out right from the start. Now the next we go from the scratch coat to the brown coat all the way over to the color coat, and we've got pretty much a completed assembly here. So what we really want to focus on at this point, we're over this Delta Vent S product, is I want to show how quickly water can actually drain between the weather barrier and the backside or the gap that's been created of this particular stucco product. So I'm just going to reach down and we're going to grab ourselves a solid pint of water, and we've put this funnel in there between, and so I'm going to dump this right into the wall, and you can see the water's already gushing out of the bottom of that wall. That is some serious, when we talk about drainage, that's some serious water release. We talk about trying to get durability, and we don't want to trap water in walls, but you can clearly see that that's far from trapping any water in the wall. That is extreme rapid drainage that we've got going on here. So that's on that back side of it. So pretty exciting to see how that works. Now, what I want to do is let's take this same product and a few other ones and look at some of the other critical detail areas that we have on the building. And so now we've constructed yet another mock-up here at CI Live, and behind me I've got a brown coat, so the second coat of a 3-coat stucco system, and we've got this side, and over here we've got the scratch coat. You can see the lines etched into it, and we've adhered some stone on the bottom portion of the wall. Most of the exact same details that we did in the first assembly have been pulled off here with just standard metal drip flashing at the bottom, diverter flashing, and then the weep screed at the bottom of the wall. So, well, a few things to point out on these details. Number one is, when we look at the interface between the stucco or even the scratch coat to where the window is, we've held that material, the masonry material, off by about 1/4 of an inch by installing a casing bead or a J flashing all the way around this window. And so the reason behind that would be, one is durability of the building. We talk about pulling off a detail with the best durability. The window may, through thermal cycling, expand or contract. And so we want to allow for some differential movement of either the building or that window. So that gap is kind of a critical thing there, so we don't either crack the stucco or cause damage to the window. So that's been done on the sides and the bottom. And at the top of the wall, we've actually installed that same casing bead, but here you can see this brown piece. Just to highlight it, we've integrated a drip cap flashing with the drip edge on it. This joint we will not backer rod and caulk. We'll backer rod and caulk these 3 joints, mostly for aesthetics and to seal it out from water or other things. But up here we want to allow for the free drainage of water, and in some cases we may even want to use that as a ventilation intake or output on the building. So that's a critical one. We're not going to caulk that joint at the top. Now, when we talk about a rain screen, there's a ventilated rain screen, a vented rain screen, I should say first, and a ventilated rain screen. A vented rain screen is one where we've just opened the bottom area of that wall up to allow air or water to pass in or out of that. The air is, of course, for drying. So when we talk about a ventilated rain screen, we're typically going to have ventilation at the bottom of the wall, but also at the top of the wall. So I'll just show 2 details that we've pulled off here to demonstrate. So number one is we've got a piece of blocking here. This is a 2x4 block. And you can see our casing bead here, which is held short by about 1/2 inch from that block. And we're about 1/2 inch to 5/8 inch thick on our stucco product itself. Up here we can see we've got this vent. There's a bug screen product that's inclusive with this system as well. And so we've got that installed, and then a trim board that's been installed here. The point is if we've got convective airflow or wind flow of air, we're able to allow air to basically escape out of this joint through this gap right here that we've created, and then our vent port right here. So it's concealed and you don't see it from the ground, and it's quite a clever way that we've seen in their installation guide to pull that off. The second one, let's really look at the whole layers of the wall, and here you can see this bug screen up here. This is a peel and stick weather barrier called Vent SA, and we've got the integrated stucco and stucco product with the lath on it right here. The casing bead sits here, so it goes weather barrier, it's the bug screen. This piece then goes on with the casing bead on top, and here's our soffit with that same air gap right up here. So from the ground, 20 feet up, you're not going to notice that. It's a nice visual sight line that's put on the building, but that's facilitating for this ventilation air to escape, and hopefully it's carrying water or other things with it to help dry that wall, so it's going to accelerate that speed. So one thing we looked at is we looked at the drainage on the back of this particular product, and so as I look at how we've got the back of this dimpled product, it's a 10 millimeter airspace, about 3/8 of an inch, and that is very wide open to allow that water, as you could see, run so quickly out of the wall. And on the front side, though, I just wanted to point out that this is the integrated wash-treated fiberglass product, but we also have drainage channels that are molded into the front of this product. And so does this allow for, and I'm going to say, we'll find out in just a second, does this allow for water to drain out of this surface and down on the front? So if I get water into the masonry material itself, does this facilitate a primary drainage plane right here, and then another rapid drainage plane that exists on the back of this? And so we want to look at that quickly to show what would happen. And so all things CI Live, we built a little acrylic box here, and we've basically drilled several holes into just the scratch coat to see how fast we could get some water drainage on the front side of this rain screen product. So here we go. I'm going to dump this water in, and you'll see it'll uptake into those holes. This may take a little bit longer for it to come out than the other one, but it's not taking too long. As you can see, there's the water spinning right out of the bottom of that wall. So we've got accelerated or rapid drainage on the front side as well. So that's pretty darn remarkable. We've got rapid drainage and ventilation on the back, and very accelerated drainage on the front side. That is really cool to see when we talk about building durability, is getting rid of that water. That's what we want to do. We want to evacuate water. We don't want to store it on buildings, especially wood frame buildings. That's a critical thing when we talk about building durability. It's about water, control of the water, control of the water. So let's just take a moment while I'm standing in a puddle here that we've created from that rapid drainage, and just recap a little bit about some of these rain screen products we've been talking about today. So here's our first product, again, the Delta Dry and Lath product, and we've got this integrated, very unique lath to it. Both of these products I'm holding have slight differences, but the ingredients are really the same. It's really about this sheet that you have on the front. It's high-density polyethylene. It's very crush-proof and very lightweight. It cuts with a standard knife or scissors very quickly, but you can see it's very light. The other is that it lays down on the wall, and we've used this on several projects, both big and small. And when we look at this product, it's very crush-proof. You saw we put metal to it. I put staples on it, but it's quite durable when we talk about its strength or compressive strength to it of installing it on the wall. So the base product is pretty much the same in 3 and possibly even 4 variations. Integrated lath on the front. This one, the first product that we showed on the wall, has this receiver sheet on the front. And what that facilitates is not using basically an asphalt or grade D paper on it, and the lath can go right on top of it. So this was a generation that sped up that process. It didn't require another layer on it. Of course, we have lath there, but we also have this product is available without this fiberglass sheet on the front, and you can just install a standard grade D paper and lath over it as well. So grade D lath and paper can be put over the raw product. It comes with the fiberglass component, and it also comes with this very unique, lightweight, cuts with the scissors, integrated lath. We've also seen it cut into strips, of 50-foot long strips, basically a 4-inch by 50-foot long strip used behind wood-based siding materials or panel products to make a rain screen as well. So it's been fun. We love to talk about rain screens here at CI Live, and this is a very interesting application. We talk about rain screens and particularly masonry claddings claddings. So at this point, we're going to say thanks for joining us today. Mark LaLiberte and I are going to be back in the shop to take some questions for a few minutes. So please join us for that.
Hey, Justin. Hey, Peter.
Buddy.
Nice job, gentlemen.
Thanks, Peter. That's a pleasure.
I thought it was very effective.
Well, excellent. So is there any question? One of the things, Justin, while we're kind of waiting for a question, I just thought we'd remind one other key thing that we touched on in the solar drive portion is that one of the benefits also to that lath, both in draining effectiveness, was that it reduces the potential for vapor drive through it as well. And so we can see,
I can't hear anybody.
you know, vapor drive would go through some of the other assemblies in terms of solar drive. And the other benefit to this is that stucco cladding that we talked about earlier in the little segment I did on vapor drive by solar, that also stops that. So we get adequate drainage, accelerated drainage front and back. We get reduced vapor drive as well on the solar side. So I think those are another aspect, as well as potential for ventilation if it's designed correctly. So I think that's really remarkable that we have those three attributes, which are so key to the success of stucco, in one application.
Well, there's some good questions come back. Can you read those on my
Mm.
monitor?
Are we able to access chat here? Or? Oh, there we go. My favorite was when Justin said that it'll ventilate water and other stuff. I wasn't sure what the other stuff you had in mind was, but it was pretty good. I like that.
You never know what somebody might be spraying on that building there. So, you know, it could be, who knows? So that's good.
Chipmunks, squirrels.
Sure, squirrels, chipmunks, yeah, low flying thing. I think that's pretty critical. But I think again, you know, Peter, that it's just been so good to see that this change in understanding that stucco has in some cases, rightfully so, received a pretty bad rap for the performance challenges we've seen with it. And I think the correct way to get stucco to work is that it's a great cladding system, as long as we realize that because of this change in thermal assemblies, slowing down drying potentials, we had to then re-engineer and reinvent the way in which stucco functions and works. And I think that, you know, I live in the Southwest, where stucco is prevalent everywhere. And we see how critical it is that stucco is going to be a choice, designing it right for the longevity that buildings deserve, you know, 50, 100 years easy for those cladding substrates. We've seen stucco last for centuries. We realize that this is such a critical function, and you get one chance at this. So making sure we get the entire assembly right the first time means remarkable long-term performance with a cladding system that's cementitious in nature and then should hold up beautifully.
Yeah, you have great points, which is why when we were looking at titles for this, I did not want to say things like problems with stucco or issues with stucco. I wanted to phrase this more positively, like this is how we can make it really good. You can use this stuff and it can be really great. And that's why I wanted to phrase it that way. Well, what's happened to me here?
There we go.
There we are.
The joy of...
I just have to figure out which way I got to move to get in the middle of this. There we go.
It's the joy of virtual everything. And so I think you're right there. And I completely agree that it's so critical that we look at all our cladding systems as systems that just need careful attention and respect of both the climate that they're in and the application of substrates, as we mentioned earlier. So stucco and any cladding system really is reliant today on understanding that because we've changed the operations, that it's going to be critical.
I've said many times, most things work as long as you have the right application, install them correctly, and have the proper expectations of them.
Yeah, I think that's so true. You know, we've seen wood claddings, for example, for years succeed and begin to fail, move towards other cladding systems. We realize that all of them, regardless, need that, but we especially realize that brick and stucco and stone. I was in Utah recently and I saw the stone application, and they're putting large amounts of mortar behind the stone, and it was probably almost 4 inches thick of mortar behind the stone, laying right on the cladding of the sheathing of the building. And again, if that's the choice of structure and design, we can realize how critical it would be that we install a drainage and ventilating mat, because imagine the amount of storage mass we have there with all of that potential for holding water. We've got to make sure we accelerate the drying and the drainage. And so if that's the choice, we have to make sure that we integrate a design for that.
Yeah. Can Justin hear us now? He doesn't look like he can.
Yeah, it's okay. So do we have any questions that we want? Can we have any questions that we want to address, or is there anything that's come up there?
I think at the outset, we should at least let people know where it can be seen after, because that's always the tip-top question. So you might as well get that out of the gate.
That's a great idea. So I believe, and Travis can share with us, but usually we're going to put this on our app as well, and this will be available for people to see on our free app, construction instruction app, as well as I think Peter, you placed this on your feed as well, which is so robust in the things that we've been able to share with Dr. Stiebrick and Dr. Straub, and other applications of people really talking about good building assemblies. And so I think that'll be available for people there as well. And we sure encourage
it'll be on our Delta Academy.
Watch it and share it with other people, feed it to others, because really so much of this is about really getting the knowledge, really getting the information out to the trades, the fields, everybody. And once we get that to everyone, we make great decisions, and much better applications will happen, and people will be happier with the choice they made. And I think that's really, really critical, Peter. And I think it's great that you've Dirk and your whole concept of making sure that education is paramount to making good decisions. So we commend you for that choice as an organization, and that commitment to training and education is vital.
I'm told there's good ones in the chat, but I can't see that anymore.
Okay, I'm not sure. Maybe one of our team mates can maybe just call out the questions to us in my ear, so that'd be fine too.
Yep.
Yeah.
You're Justin getting his mic adjusted?
Yeah, he's just the whole thing about technology and everything. So one of the questions, Peter, was the top of wall bug screen, and I know that there's a couple different methods for that. One is that I believe that you have a kind of a fibrous mat material that can be placed along the top, and then the
material just butts against. Yes.
So what that looks like is, I think it's a mat, and it can be placed against. So then we staple the material into that, so that there is the ability to keep bugs out, but also for air to flow through that. We have seen also an application where somebody will take a vented piece of lath material. There's one kind of a rain vent product that goes on there, and you can wrap bug screen around it and then attach that at the top edge and then secure it. But I think it's critical that at the top edge, it's either a material that will allow airflow. Yes. Sometimes we get things that are too restrictive, and I think that happens. Otherwise, it can be, like I said, an insect screen with some venting space, or I think you have that mat. Is that correct, Peter?
So it actually butts up against it, Justin. Our original details actually called for basically wrapping the ends with screen, but people found that basically too much work. So we went to this strip where you can just butt against it. It doesn't go, the dry doesn't lap on top. You just simply butt it up against it.
Okay. Justin, can you hold that a little closer to the camera? Because it's pretty cool. I think that there's a lot of applications where we can see.
Yeah. It doesn't go behind, Justin. It goes on top.
On top. Okay. All right. Cool.
No, that's not right. On top. On the top edge.
You're right. It could go both ways, Peter. Actually, we tried both of them, and if it's set on top like that, it works, and that's really a nice application as well.
It would. The only risk with it behind is sometimes, particularly with stucco, you get a bump out. Yeah, or it creates a bump out, and the stucco guys don't like dealing with that.
Very fair. That's good field feedback, I think they call that.
Yeah.
So All right, did we have another question
if
that
you
was
want.
up at all? Justin, well done. There you go, that's
Wow.
perfect. Yeah,
The Delta product with built-in fiberglass mesh does not require a metal lath before stucco strapping.
that's correct. The question was, is the fiberglass, lathing product on top of the
Hmm.
stone and lath product does not need an
Hmm.
additional metal lath over the top of it. It actually acts as the lath for the assembly. And
Correct.
in the shop, we've been doing this. We've taken stucco and applied it directly, of course, onto the fiberglass meshes, which it is an approved lath material. And the embedment and the bonding, because it goes through and there's those channels behind it, we found the embedment was remarkable. I've seen many cases where I'm seeing stucco being installed where they'll use a chicken wire and lay the chicken wire up, and when they put the lath on, it barely gets in contact with the chicken wire. So the wire is just on the back side, but really not bonding well. And I watched how the stucco got put into the stone and lath, and it really went through nicely. When we tried to pull it apart, you couldn't get the lath out of there. So you don't need an additional metal lath in front of the stone and lath. That fiberglass mesh is the lath product, which means no more cutting metal, pokes and scratches and all the things that go with it. You roll it out in one application, you secure it, and you scratch to it. It's a really fast way of getting that on there without that additional step.
And code compliant.
And it's code compliant as well. And I think that's like we said, when we play around with stuff in the lab, Justin always is pushing things as hard as he can. And we've been so impressed. We actually had a stucco guy, an old world stucco guy, had been 30, 40 years in the stucco industry. He came along, he looked at it, and he's one of those guys kind of scratching his chin a little bit and kind of looking like this. And he went through it and he said, that was amazing. And he had his stucco application, he did it. He goes, I wouldn't do it any other way. He said, putting lath on is such a complex problem because trying to get the metal all together, and like I said, it's sharp, and it's just one extra step. And to not have to put that on and to know that you're getting front side drainage and back side drainage, plus eliminating the potential for vapor drive, solar drive basically, because of the impermeability of the material, that kind of gets all of those functions in one application. So weather barrier's on, you roll it on, and you start to scratch to it. It's really, really, really smart.
So some people want to know about exterior insulation, in particular rock wool or a stone wall on the exterior. So the order of that would be your air and water resistive barrier to the inside. Then you could put on your mineral wool, your rock wool, and then you'd put the Delta Dry in front of that. That works very well because the rock wool is permeable.
That's correct. Yeah, and there's always those interesting strategies about where you apply that. Of course, we know that if we want to drain that front side product, which is the stucco on application there, and we also know that putting a weather barrier at the sheathing interface, whatever insulation goes over the top of that, then protects the sheathing interface with the foam, and then we can put the draining materials and scratches and substrates on top of that. And so really securing it back like we usually see. Oftentimes we're going to see that with thermal insulation beyond an inch, we have to go with a 1x4 or a board going back to holding those cladding materials back on, which does provide us some additional strength. The benefit of the mineral wools are that we really don't have as much challenge. It drains effectively. We also know that insects don't like it. And so there's some other benefits to the mineral wools.
Must have some other questions. Let's see what we got.
Yeah, that's a really good question. The question is what are the recommendations for EIFS, and are they same or are they different? The challenge with EIFS is, of course, that we'd have sheathing. In some cases, I'm in Arizona where we don't even have sheathing, but you'd have your weather protection layer, and then what we'd really find is that a layer of foam. I usually here in the Southwest, through California, Nevada, and Arizona, we would see a 3/4 or 1 inch piece of expanded polystyrene. A pretty low density product would then be installed and just nailed on. Then they would lath on top of that, oftentimes paper there, and then they'll scratch right to the lath. And so what we do in those applications is find that there's really sheathing and your drainage layers in play. If the foam layer is installed, you then put the stone and lath on top of that, and then scratch to that surface as well. And then you EIS is different. We know that there's not as much storage in the cladding in the reservoir facing because it's fairly thin, and so we have less concern for vapor drive. We know that if we could put the interface and the draining layer back behind the foam, that's equally effective. We have put sheathing, the drainage layer, and then the foam on top. And we've seen that in below grade applications. We do it above grade. We have the potential, if it's ventilating, is to reduce the thermal performance of the insulation. So that's basically what we see in those characteristics.
Yeah, eaves generally have a proprietary water resistant barrier and drainage function to them that are required in order to meet their warranty requirements.
That's correct. Yeah. Well, oftentimes, weather barrier, and sometimes the foam on the backside is grooved to provide drainage. There's a liquid applied and mechanically attached as well.
Yeah.
And we are seeing a few more EIFS applications. We have another question. It says, Peter, are there details available that coincide with the mock-ups that we installed there?
Yes, there are. You can just go to durkin.com and use the big master product drop down that's on the address bar at the upper right. Click on Delta Dry or Delta Dry Stucco and Stone or Delta Dry and Lath, and that will take you to the page, and then you'll see on the right architectural details, and we have full sets of details for all of those. Yes, they're right online.
Excellent.
I can't remember if they're in your app right now. I think they're in your app as well.
I think so. I think we have some of those details in the app, and we also have some animations in the app that show that approach as well.
Correct.
And so again, people can take that the animations and the app as well as your materials and get a really good program pulled together. So, for example, you could have somebody watch today's session, look at the details, and then apply them in the field. As you know, we're basically looking at CI Live. We're big fans of mock-ups, and I think that it's so critical that we build mock-ups. Like I said, I was at a project in Salt Lake City a few weeks ago, and the idea about building mock-ups on site gets everybody on board. So you put the detail together, even if it's a small one. We look at a critical spot where there's maybe a couple interfaces. Justin showed us in that application in Denver. I think there were 3 or 4 cladding systems that somehow all were supposed to come together at the same time in the same spot with 3 different trades. So building a mock-up helps everybody go and look on site. So if you have a complex detail, we're really strong advocates of putting together a mock-up. So take the detail from the Durkin site, build that assembly, and then apply that in field. And it's a remarkable layer of success when everybody just knows what you're trying to achieve.
Yeah, mock-ups are a great way of making sure everybody understands their role and the importance of the details.
So true.
Yeah.
Well, we don't have. I'm not sure if we have any more questions. Matt, do you know if we have any more? There we go.
We do.
Would there be any differences if the system was to be applied on a curved wood framed wall? I think actually not really. Basically, if we look at a curved wood frame wall, we would take those couple layers of plywood that we're going to be using, usually 1/4-inch pieces or even 3/8 if we can get them to curve, and then round the wall and then apply the same application. The challenge with conventional stuccos are just that we do need some break lines, and we don't do that very often anymore. We see here in Arizona, there's almost no break lines for the stucco, and it's because people like kind of that monolithic look. So I would sure advocate that if we have the weather protection layers on the sheathing interface, which would be usually layers of plywood, is most oftentimes for curves, is applied, then the weather protection layer is on, then the stone and lath goes on very nicely because it follows the curve beautifully. You would then scratch and finish your layers, whether you did a brown and finish or just sometimes we see scratch and finish, just 2-layer. But in those applications, you could do that straight on the stone and lath because it would curve so nicely and you wouldn't have to try to make the metal go around the corner. So I think that's what they're asking. I think that's a nice way of doing that, and the curve would be well done. Great question.
And you touched on another detail that people often ask, and that's expansion joints. Yeah. As many cases stucco needs it. That's all installed right in front of the of the dry. You don't have to install it back to the substrate and then muck with the dry around it. You just install it in front of the dry. That's all. So it doesn't really change anything.
Yes, expansion joints, and we see control joints are so seldom used anymore, and I think that they're pretty important. When you look at the lath and plaster bureaus and the stucco groups, associations would really like to see a better use of expansion joints and the details for brake lines. But I too often see that no one puts them in. So when you look at the spider cracking and the things going on, it's more difficult. So if we would see a few more control joints there in terms of expansion joints, that would sure be good. We're using full stucco applications. And if not, be very careful about how, like Justin did such a good job of explaining around windows and penetrations, how we isolate the stucco from being in contact with something like a window or penetration that would expand and contract and even create further stress on those joints. So I think you were right. It's nice to put that expansion joint right on top of the stone and lath, and then you don't have to bring it back to sheathing.
Right. We have another question. We do.
Yeah. It says, do you have equivalent products for the roof?
Not in the same sense of the dimple membranes. We do all of our membranes have been used for many years in roofs across Europe, particularly under tile roofs as the secondary barrier.
Yeah.
But I mean, that's a pretty general question. It depends what you're doing on the roof. Are we a sloped roof? Are we a flat roof? What are we doing with this roof? So there are things that can be done. It wouldn't be Delta Dry, but there are things that we can do on a roof depending on what your goals are and what your materials are.
Yeah, I'll just a couple quick comments that I'll have. Here in Arizona, we're in the Southwest, we see a lot of tile roofs, Texas as well, and they often put tile on top of a wood batten, and we see the wood batten fail continuously, and so it's really awful. I've seen houses at 15 years, they'd lift the tile and the wood batten, which was attached right to the black paper on top of a piece of OSB. That whole piece is rotted right there. And so I've seen a plastic batten. One's called Eldorado batten is one of them, but it's a batten where it's kind of, they call it battens. Plus, it runs across there, and it's like a half-inch batten. It's structural. It meets the code, and you can have the water run straight through it. And I know in Europe, they could look at those kind of strips where if the water gets uniformly past that, the tile holds up well. Some tile manufacturers have actually created a little knob at the bottom of the tile to hold it up off the roof to get that to run through. So they'll hook on the backside and then hold the tile up. I'm really not a very big fan of the wood battens. I think that's a horrible idea. We have seen the wood battens now come up with a plastic, kind of a rigid plastic washer that's on the bottom side of that batten. So now when you staple the wood batten down, there's a gap under the bottom side, somewhere in the range of less than a quarter, about 3/8 of an inch at the bottom edge underneath that. So they staple that down, the water can at least run under the wood batten. That's a much better step up from conventional. I would never install wood battens directly against the paper and sheathing. Again, I think it's a terrible strategy. And now we have insulated roof decks that even further challenge the details. So I would say we've got to be kind of careful with that one. If you have flat roofs, Peter, I'm sure there's applications where we're seeing cement roofs being flat and allowing things like FL and other things that allow drainage to occur underneath there. But we know that ventilation really doesn't occur very easily on a flat roof. So strategies of isolating water and providing drainage is got some other benefits to it. So it depends on the roof type.
Right. If there's not another question, Mark, there is another question.
Yes, it says, should the bug screen be used on both top and bottom of the wall? And the answer is, of course. We know the tenacity of bugs, so we would recommend a bug screen. I think Justin did show the application of putting a bug screen on the bottom, so there's that kind of layer where the lath comes down, and this Delta's dry stone lath sits down, and that same material can be placed at the bottom to allow to inhibit the entrance of bugs coming up the backside, as well as the same at the top side. So we would advocate a bug screen at bottom and top to prevent a place for insects to enter. I was at an application where we saw applied stone on a wall, and they had bees that had built a beehive behind the wall, and there's actually honey oozing out through the mortar joints. So it's important to keep the bugs out of cavities. Non-harvestable honey, might be. Well, that's the
Yeah.
last question we
But,
have, Peter. And I think, again, I want to thank you and Durkin and the team that you've put together. And again, people can look at this event, go on at the CI and look at the app. It's free. Thousands of assets on the CI Live app, as well as on your site. And you'll upload that to your portal. This is now kind of about this whole idea about managing water and rain and drainage. You've done a beautiful job of pulling that together so people can go to the Durkin site. And you want to just give spell out the website for people if they wanted to make sure they get that in case they can't quite get the Durkin part.
sure. The main site is dorken.com, so dorken.com. And when you're there, you can find videos and a lot of other learning information over on the Delta Academy button. So the Delta Academy button is right at the top of the page, and that'll take you right over to videos and blogs. For our part, Mark, we're always so pleased to work with the experts at Construction Instructions. You guys really focus on teaching the builders to do it right, and that's why we like to be associated with you, because you focus on the education and doing it right so that the end user out there gets a really good product and what they really want, which is a comfortable, dry house to live in. So from me and all of the team at Durkin, we thank you. We thank Justin and Gord when we work with Gord as well. And while we're here, we wish everybody the merriest and safest Christmas.
We agree, and we'd like to also hope that everybody stays healthy. We know these are challenging times, and we sure encourage you to continue this learning curve throughout this difficulty. We hope the best for you and your families, and we look forward again. What a great holiday, Christmas, such a wonderful time of year. And we thank all of you for joining and participating. Best of luck, and we'll see you in the new year.
Thanks everyone for coming out. Thank you.
Yeah. Appreciate the time.